Okay, 2019 paper. This time, no polynomial provided to you, the original one. So it just tells you that it's a cubic polynomial. It means that the highest degree is x to the power 3, the highest degree. Okay, so we need to find out the polynomial by ourselves. First information given to you is x minus 1. When we divided by x minus 1, the remainder is 50. And then second information, divided by x plus 2, remainder is negative 52. And then third information given to you is that px is divisible by this quadratic equation here. It means no reminder, okay? So we use the information one by one. First, p1 equals to 50. The second one is p negative 2 equals to negative 52. As we don't have the polynomial, we cannot substitute the x in. So the third information given to us is that the polynomial is divisible by this quadratic equation. So what we do here is we try to form the polynomial by division algorithm. Because no remainder here, so you don't need to plus out. No remainder, right? Okay, so this is the factor. This is the quotient. Why we know the quotient should be ax plus b? A and b, actually we let it into constant. Actually we don't know what is a and b, but we know that the quotient, the highest degree of the quotient should be just 1, should be x to the power 1. Why? Because when these two times together, the highest degree should be x to the power 3, x cubed. So this x here won't be to the power 2, it means square. Here won't be x squared. Why? Because when they times together, it will be power 4. So here, we know the highest degree is 1. The constant we let here, it includes all the possibility, right? It can be negative, it can be positive. Here it can be negative, it can be positive. Okay, so when you have this information, now we put in the p1 and p negative 2 to help us find a, b, the unknown we let. So p1 equals to, put x equals to 1. And then here also equals to 1, a plus b. After we simplified it, is a plus b equals to 2. First equation, p negative 2. And then we put in x equals to negative 2. You will have this one, negative 2a plus b. And then you simplify it. You will have the second equation, negative 2a plus b equals to negative 13. So equation 1, equation 2 solved by your calculator. A equals to 5, b equals to negative 3. So when you have this, actually you have the whole polynomial. You have found out the complete polynomial. So what is the question asking? It's the quotient. It's the quotient when px is divided by this one. Okay, the quotient here should be 5x minus 3. And then part B. Be careful of that. This question asks how many. How many means that you need to find out all the roots and then count how many rational roots does the px equals to 0 have. So we find all the roots first. Do we know a factor yet? Yes, we know, right? We already know this one is the factor. So this time, we don't need to do the factorization because we already know px is this factor here times the quotient and no remainder, okay? So check this one. When we meet the quadratic equation, we always check with formula 01 to see any roots, to see any real roots. So it shows math error, it means no real roots. The only root here should be 3, x equals to 3 over 5. Okay, but you need to show the marker, right? You need to show the marker is unreal. So the discriminant of this one, smaller than 0, it means no real roots. So no real roots and no rational roots. As we say, rational root must be real, right? So no real root means no rational roots for the quadratic equation here. So px equals to 0 only have one rational root, which is x equals to 3 divided by 5, this one, which is 3 over 5, okay? So it asks how many. You must tell at the end how many of it.